much for all. And so I'm pleased to have a presentation here. So firstly, please let me introduce myself. And thank you very much for introducing me, Chairman. So my name is Takashi Kamijo. I'm working for Mitsubishi Heavy Industry Engineering. And I'm Chief Engineer Manager. And I have a long experience working with MHI shoot capture project over the last 25 years. So today I'm going to talk to you about MHI shoot capture technology. And at the end of the presentation, you'll be able to understand the current status of our technologies. So let's start by our company brief. And so Mitsubishi Heavy Industry, MHI, was founded 1884, and we have the 18,000 larger employees, including affiliated companies. And our product covers a variety range from power plant, launch vehicle, fighter, turbocharger, chemical plants, compressor, and infrastructures. And so shoot capture system is taken care by Mitsubishi Heavy Industry Engineering, which belongs to the Mitsubishi Heavy Industry Group. This is the overview and feature of our CO2 capture technology, a so-called KM-CDR process. K stands for Kansai, M stands for Mitsubishi, CDR carbon dioxide recovery process. Yes, this technology is jointly developed with Kansai Electronic Power Company, which is a second largest utility company in Japan. And our technologies use hindered proprietary organoid amines, so-called K-strand. And it's a very traditional and conventional scheme, gas quencher absorber generators. However, we apply several proprietary equipment system, not limited to the solvent. For example, amine washing system in the top of absorber to reduce volatile organic compound and emission from the absorber, and case 1 solvent, and sometimes we use the case 21 solvent, the new solvent recently, and superior solvent, high CO2 capacity, low degradation, and low regeneration energies. Also, we apply automatic load adjustment control systems and to follow the operational fluctuation and quick change of operation load of mother plant. And so, for example, the gas turbine and coal fire plant operational load quickly change. So should capture units should follow such operational load change. So, but our system can follow this such operational fluctuation. Also, we have proprietary heat integration system and towers, reboilers, based on our proven technology. So here you can see our extensive commercial record worldwide, and we have delivered 13 commercial plants in operation and 2 shoot capture units in construction now in Russia and Bangladesh. And so, as you may know, we delivered world largest shoot capture plant in USA, Texas, and the capacity 4,776 tons per day, and world largest capture unit. So here is a list of 13 plants and the 2 upcoming plants. And our commercial plants range, commercial record ranges from 200 tons per day to nearly 5,000 tons per day. And the purpose of CO2 is mainly for chemical production, especially urea, methanol, and the general usage. And general usage means beverage and dryers, and welding, so on. So largest one in USA, the CO2 captured CO2 is used for enhanced oil recovery. So our technology can also apply not only for gas, but also low pressure process gas. And so unfortunately, we don't have the commercial experience, but we believe we can apply a low pressure process gas without any technical issues. So now I would like to look at some specific applications that we currently working on. So as I introduced you, this is the world's largest CO2 capture unit in USA for Petranova, which is a joint venture between NRZ and JX Nippon Oil and Gas. And the capacity of 4,776 tons per day, and plant scale it's equivalent 240 megawatt equivalent. And the captured CO2 is compressed and dehydrated and transported by 81 miles length pipeline to the oil field, where the CO2 is injected in the oil field for enhanced oil recovery purpose. So unfortunately now this plant is shut down because the last year's crude oil drop, and but we are expecting this plant and starting up again soon. This is another example. This is drugs, UK, and drugs and which I have agreed a long-term contract, and so for use our shoot capture technologies. And so far we are discussing with them to install a very large, a huge shoot capture unit with 8 million tons per year capacity, and so which is 6 times larger than, 5 times larger than Petranova, if it is realized. Also now we bring the small mobile testing unit facility to drug site, and we are now testing and capturing CO2 from a biomass flue gas. So if this project is realized, please note this is a negative emission because the capture CO2 from biomass flue gas. So we are considering so many applications: gas-fired, oil-fired, and coal-fired, cement gas, and steel plant, and refineries, and so on. And we have many deep knowledge about impurity in the flue gas. And also we understand the features and also the characteristic of each flue gas from different industrial sources. So next is the example of the demonstration test in TCM, Technology Center Mangstad. And so we are testing a new solvent, Case 21, and in Norway TCM plant. And so we tested from this May to August, and we completed the test. And amazing, we achieved 99.8% CO2 capture rate for gas turbine flue gas. So it means absorber outlet CO2 gas is less than 400 ppm. So CO2 concentration is less than air CO2 concentration. This is another application, capture CO2 from liquefied natural gas plant. And so the plant site is USA, Texas. And so now we are carrying out basic engineering. And so our duty is limited to the preparation of design package and for contractor to proceed the detailed engineering. But we think this is a new application with CO2 capture unit. But if this plant is constructed, the new LNG plant arrived. So new LNG plant means usually when the natural gas is liquefied, many CO2 is emitted, roughly near 10% of produced LNG. But this plant captures CO2, such CO2 emission. So this LNG is very, very green. And this application is the pre-feed study for cement manufacturing. And our technology is also a great option to reduce CO2 from cement facilities. And as you know, cement plant flue gas contains a lot of impurities. And so yes, so that is a major challenge for our technology. But we understand what impurities exist in the flue gas, and we have a countermeasure for each impurities. So we believe our technology can respond effectively and perform well in such a dirty flue gas condition. So this is another example in the steel plant. So we carried out the demonstration test for steel plant in Japan. And this is the small scale, but we confirmed that our technology can be applicable for steel plant. So this is a very unique application. And this is carbon capture from the ship. And Mitsubishi Heavy Industry produced the ship. And so as cooperation with shipping department, and we are working with to install small unit on the ship to capture CO2 from engine exhaust. And this is currently in the development phase. And we are verifying our carbon capture process can be effective in marine environment. So this is the last page. So this is the CO2 value chain. So we focus on CO2 capture unit, and this is a start line. But in future, also we would like to expand our product to the CO2 conversion and the CO2 utilization, because in order to become the net zero society, and the CO2 must be utilized. And of course, CCS and is a very important option to reduce CO2 emission. However, in order to create the net zero society, we think CCU and CO2 utilization is also very important. So that's why we like to expand our product range to the CO2 combustion utilizations. But that's we are just starting. Okay, so thank you very much for your kind attention. And
thank you. Thank you, Takashi Kamijo-san.
Yeah.